So there's this massive shift happening in the tech world, but it's not the one you might be thinking of. It's not about software, it's about the raw electricity that fuels it. Today, we're going to dig into AI's ultimate power play, the race to build these self-sufficient energy islands. Think about that for a second. The era of plugging in is over. That one statement signals a pretty radical change. For the absolute giants of AI, the old way of doing things, just connecting to the public grid, well, that's just not going to cut it anymore. So, what in the world is an energy island? It might sound like something out of a sci-fi movie, but it's becoming very real. We're talking about a completely self-sufficient campus that creates all of its own power, totally separate from the public grid. It's like building an energy fortress with the single purpose of powering artificial intelligence. Okay, so this brings us to our first big section, the failing public grid. We're going to explore exactly why big tech is so desperate to unplug from the very system that's powered the world for more than 100 years. I mean, it seems like a pretty drastic move, right? Why go through all the trouble of building your own power plant when you can just, plug into the wall? Well, the answer is actually pretty simple, but the implications are absolutely huge. It's because the public grid itself has basically become a liability. It's now seen as fragile, leaky, and even an expensive tax on intelligence. I mean, get this, up to 5% of all electricity generated is just lost during transmission. When you're talking about the exponential growth of AI, relying on a system like that is a chokehold they're trying to break free from, and fast. And this comparison right here really gets to the heart of it. The public grid is seen as this fragile liability. It's unreliable, it's inefficient. An energy island, on the other hand, is a self-sufficient asset. This is a huge shift in thinking, right? It's the difference between just renting power and owning the entire energy source yourself. All right, so if the old grid is the problem, what's the solution? This is where some fascinating new tech comes into play, the Small Modular Reactor, or SMR. And there's one company, NuScale Power, that's positioned right at the front of this whole movement. Yep, NuScale Power, you can find them trading under the ticker SMR, is being talked about as the potential battery for the entire AI revolution. They're the ones with the core technology that could actually make these energy islands a reality. So what's so special about their technology? Well, unlike those massive traditional nuclear plants that take like decades and billions of dollars to build, small modular reactors are just what they sound like. They're smaller, they're safer, and they're built in a factory. Now, NuScale's edge really comes down to two key things. First, they have this massive regulatory moat. Their SMR is the only design that's been certified by the U.S. Nuclear Regulatory Commission. That gives them a huge head start. Second, they've created a modular standard. These things are built in a factory, shipped to the site, and installed as needed. You need more power? You just add another module. Simple as that. And that is why it's being called the ultimate energy subscription model. You see, tech companies aren't just making a one-off purchase of some giant power plant. They're basically buying into scalable, on-demand energy that can grow right along with their AI ambitions. And the real key here is standardization. Each one of NuScale's Voyager modules provides a standard 77 megawatts of power. So a tech campus can start with exactly what it needs, and then, as its data centers and AI demands grow, they just add more modules. It's predictable, it's repeatable, and it's incredibly efficient. NuScale's journey is a really important part of this story. They basically went through this death valley of project cancellations and a ton of skepticism back in 2023, but they survived and came out the other side even stronger. Now, they are positioned as the potential standard for all off-grid AI power. And that kind of resilience, well, that's a really powerful indicator. So, for anyone watching the markets, the key things to look for might not be simple revenue numbers. Instead, the focus should probably be on the order backlog from big tech, like who is actually lining up to buy these things, and the company's cash flow stability. Those are seen as the real signals of this emerging energy giant. Okay, let's zoom out for a minute. This isn't just about tech or business. This has massive, and I mean massive, global implications. So in our final section, we're going to look at the new power map and all the geopolitics, performance, and protectionism that come along with it. And this is all broken down using what's called the PPP framework. First up, politics. This is a flat-out race for AI hegemony, where owning your own power source is the key to dominating AI development, especially in the competition between the US and China. It's not just about code anymore. Second, performance. The whole business model flips to power as a service, which creates this ongoing, predictable stream of revenue. And third, protectionism. By building these local, self-sufficient energy AI hubs, countries and companies are basically creating brand new kinds of economic fortresses.
When you strip everything else away, it all boils down to this one simple, incredibly powerful idea. The companies that own the power own the future. Energy independence is now directly tied to having ultimate control in the age of AI.
So we're left with this final, really provocative thought. The source declares the cloud has landed. What that means is the abstract idea of cloud computing is now being physically tied to real self-powered locations on the ground. And that leads us to the critical question we all need to be thinking about. Who is going to own the future?